Hey everybody, welcome back to another video lesson. This is Mr. Kozad, and as always, I gotta tell you, today is a great day to be alive. I'm so happy that you found us and hope that this video is helpful for you. Our topic for today is how to rationalize radical denominators. So, best way to use this video is to either watch it on your own, pause it, take some notes, and I hope that however you choose to use it, it's beneficial for wherever you are and whatever you're working on. So how to rationalize radical denominators, okay? So we're going to start pretty easy with rationalizing simple denominators. Now, we know in what we should know from our history is that when we have the square root of a fraction, we can split this up to the square root of the top over the square root of the bottom. So in this case, square root of 27 over the square root of 8. And then we can go through, and what we find with square roots is we're looking for a factor of this inside number that is also a perfect square. So we know, for example, that 27 can be rewritten, I'm going to move it down here. 27 can be rewritten as 9 times 3, and 8 can be rewritten as 4 times 2. Now, the reason that 9 and 4 are special is they're perfect squares. So the 9 actually comes out of the radical as a 3, and the 3 is trapped on the inside of the radical. And then this 4 comes out as a 2, and then there's a root 2 left over on the bottom. Now, one of the kind of generally accepted rules in math is that you're not allowed to leave a radical in your denominator. So what you would know to do from Algebra 1 is to multiply both the top and the bottom by the square root of 2, and that'll get rid of it for you. So the top would become square root of 3 times the square root of 6, all over that first 2 that you had, multiplied by the square root of 4. Square root of 2 times square root of 2 is 4, and when we multiply those together, obviously we get 3 root 6 on the top, all over 2 times 2, which is 4. 2 times 2, which equals 4. So that's pretty easy. It gets a little more interesting when we no longer have a square root, but we have a cubed root or a different type of root, okay? So the first step here is to split this up into the cubed root of the top, which is 27x to the 4th, all over the cubed root of 16. Now, the purpose of this video is not necessarily to help you simplify nth roots. That's another video that you can watch. This one is specifically designed to help you simplify denominators that have radicals in them. So here's what we're going to do. We're going to take the top and simplify it. So I'm looking for a number to the third power that can come, that's a factor of 27. And actually, I could rewrite 27 as 3 to the third times x to the 4th, all over the cubed root of 8 times 2. 8 times 2. Now, on the top, 3 to the third comes out of the cubed root as just a 3. X to the 4th can also come out as just an x, and I'm going to have a x left over on the inside. Again, if that step doesn't make sense to you, why that x to the 4th comes out as an x and an x is left over on the inside, go find the video on nth roots, okay? Now on the bottom, the cubed root of 8 comes out as a 2, and I still have the cubed root of 2 left over. Now this is where it really starts to get kind of difficult for people. I'm going to move this up here just to give a little bit more room. This is where it starts to get a little weird for people, is how do I get rid of this cubed root in the denominator of this fraction? And here's the best piece of advice I could give you. To get rid of this, you want something so that you have the cubed root of 2 to the cubed root of 2 to the third power left over. So right now what we have is we have the cubed root of 2 to the first power. Well, if I want to multiply that by a cubed root to get it to be to the third power, I'm going to multiply it by 2 squared. Because if I do the cubed root of 2 to the first times the cubed root of 2 squared, that's going to end up giving me 2, that original 2 that I had, times the cubed root of 2 cubed. So if I do that on the bottom, I have to also do that on the top, the cubed root of 2 squared. So cube root of 2 squared on the top, cube root of 2 squared on the bottom. Multiply that out. I get 3x times the cubed root of, running out of room here. So let me slide this over for a minute. There, I'll get a little bit more room. Cubed root of this first x times 2 squared would give me 4x inside the radical. So then, as I simplify this one step further, the top stays the same, 3x times the cubed root of 4x. And on my bottom, I had that original 2 that we factored out at the beginning, and I multiplied that by the cubed root of 2 cubed is just 2. So then clean that up one more step. We have 3x times the cubed root of 4x, all over 2 times 2 gives me 4. And that would be my final answer. Okay, let's try another one of those. Okay, so if you are doing this yourself, maybe try pausing this video here and see if you could work this out on your own. Okay, if you're not interested in that, we'll just do it together. So first step here is to split this up to the 4th root of the top, which is 32x to the 5th, all over the 4th root of the bottom, 3y squared. So I'm going to simplify the top as much as I can. Okay. So I'm looking for a factor of 32 that is a 4th power. So 2 to the 4th is 16, and 16 is very clearly a factor of 32. So I'm going to think about this as 16 times 2 times x to the 4th times x. Now the reason that I'm splitting that up is to just kind of show you why the x to the 4th comes out the way that it does. Okay, in the bottom there's actually no factor of 3, because it's a prime number. So there's obviously no factor of 3 that's a 4th power. And y squared, because that exponent is less than the index, we can't simplify that at all. Okay, so what we can do next is this 16 is going to come out of the radical. It's going to come out as the whatever the 4th root is. So the 4th root of 16, it comes out as a 2. And then this x to the 4th right here also comes out as just an x, because the 4th root of x to the 4th is just x to the 1st. So then you still have some things trapped in that radical. You've got a 2 and you've got an x left over. So then let's clean up our bottom here. Okay, so on the bottom I've got the 4th root of 3y squared. Now we want to get rid of that radical in our denominator, so we want to try to figure out what do I need to multiply the top and the bottom by to get rid of that radical. So you start by, you know it's going to be a 4th root because that index has to match the index over here. And we want 3 to the 4th. So currently over here we have 3 to the 1st. So to get that to be 3 to the 4th, I'm going to multiply that by 3 cubed, because 3 times 3 cubed would give me 3 to the 4th. Now the same thing over here with the y. Right now I have y squared. So to get that to be y to the 4th, I need to multiply by another y squared, because y squared times y squared gives me y to the 4th. So if I multiply by that on the bottom, I need to multiply by the same thing on the top. Okay, so let's see what we have. So start with the 2x that you already factored out. Okay, then we have the 4th root of 2 times 3 cubed. Well, 3 cubed is 27, so 27 times 2 would be 54. Xy squared on the top, and on the bottom I'd end up getting the 4th root of 3 to the 4th times y to the 4th. And very clearly we can see that we did this correctly, because the bottom simplifies to 3y. So final answer would be 2x times the 4th root of 54 xy squared all over 3y. Final answer. Okay. Now those are simple denominators because there's only one term in the denominators, but what we can actually also do is we can rationalize not so simple denominators. So when we see not so simple, what that means is that there's multiple terms in your denominator. Clearly you can see we've got 2 terms here. So what you're going to do when you see not so simple denominators is you're going to do something called multiply by the conjugate. Multiply by the conjugate. Now, what is a conjugate? Well, a conjugate is you take that same denominator and you write it out almost identical to how you see it with one small change. You take the sign in the middle and you make it the opposite. So the conjugate of the square root of 3 minus square root of 2 is square root of 3 plus square root of 2. Remember, whatever you multiply on the top, you have to also multiply on the bottom. Okay? So we'll do our distributive property here again. Okay, so the top is going to be 6 times root 3 plus 6 times root 2 all over square root of 3 times the square root of 3 is 3 minus the square root of 6 plus the square root of 6 minus 2. So I just FOILed that out. I FOILed bottom times bottom. And if you did this correctly, you should see that those middle terms do in fact cancel out. That's the whole purpose of the conjugate. So the top becomes 6 root 3 plus 6 root 2 all over 3 minus 2, which would give me 1. So this is going to simplify to 6 root 3 plus 6 root 2. Final answer. Now remember that you cannot combine these. They're not like terms. For radical expressions to be like terms, you have to have the same number on the inside of the radical. Okay? So if we try another one, same kind of deal. Pause the video now and try it yourself if you'd like. If not, if you're on a time crunch, we'll just do it together. So I identify my denominator here is not so simple. So I'm going to multiply by the conjugate. So the conjugate of square root of 3 plus 6 is the square root of 3 minus 6. So I multiply by that on the top and the bottom. And then I'm going to FOIL the top and the bottom both. So 9 times square root of 3 is 9 root 3. 9 times negative 6 is negative 54. Negative 2 root 3 times root 3 is negative 2 times 3, because the square root 3 times square root 3 cancels. And then negative 2 root 3 times negative 6 is plus 12 root 3. That's the top. The bottom, root 3 times root 3 is just 3. The middle terms will cancel out, and then I'll have 6 times negative 6 is minus 36. So last step is to combine some like terms here. So on the top, I have 21 root 3. I can add those together because they're both root 3 terms. And then I have minus 54 minus 6 more. That gives me minus 60. All over 3 minus 36 is negative 33. And then don't stop there. If you're a big leaguer, you want to get all the points you can. Notice that you can also factor out a 3 from all three of those terms. So that can be simplified to 7 root 3 minus 20 all over negative 11. And that is how you simplify not so simple denominators. Hope this is helpful. If you liked it, hit the like button and subscribe to the channel so you can get all the updated videos. I know it's not as fun as all the other stuff on YouTube, but it would mean a lot to me. So we'll see you next time.